Good morning. Welcome to AP Statistics. This is a summary of the lesson that was taught on Friday, November 8th. So let's take a look. First of all, we're looking at the concept of a simple random sample that Party Sabetti described on her video as being characterized by having each individual has equal probability of being selected. My contention is that that's an unhelpful characterization because that's the same contention, or that's the same characteristic as you have for a cluster sample where every individual is equally likely to be selected or included in the sample. So a better way to talk about a simple random sample is, and again, this is, if you're wondering, wait, didn't we talk about this before? Yes, we talked about this before, but this is an example. On Friday, November 8th, I gave an example of why. It's actually a numeric example that illustrates this a little bit better. So simple random sample is characterized by not each individual, but each subgroup. Each and every subgroup of size n is equally likely to be selected. So I want to give you an example of that so that you can see exactly what we mean. Suppose we have 9 employees, 4 of them are male. Let's assign integers from 1 to 4 to the males. Male 1, male 2, male 3, male 4. Let's assign integers 1 to 5 to the females. Female 1, 2, 3, 4, 5. And let's contrast 2 different sampling methods. One sampling method will be the stratified sampling method, and the other will be the simple random sampling method. In a stratified sampling method, what is the probability that the first person selected will be male number 2, and that the second person selected will be female number 4? Well, now again, this is not just any old type of subgroup. This is an ordered subgroup because I'm saying male is selected first, female 4 is second. So we're looking at something a little more specific than a subgroup, and that is, it's a special type of subgroup called an ordered subgroup where order matters. If order didn't matter, we would be using combinations. But here, there's 1 out of 4 males. Female 4 is 1 out of 5 females, so the probability is 1 out of 20. Whereas if this were a simple random sampling method, we would pool all 9 people together. We would say that the probability of male 2 followed by female number 4 being included in the sample would be male 2 is 1 out of 9 people. Female 4 is 1 out of 8 remaining people. When you multiply those together, you get 1 out of 72. So in simple random sample, the male stratum and the female stratum are pooled together into one group. Let's take a look at the probability that male 1 is the first male selected, or is the male selected, and female number 1 is the female. It's 1 out of 4 times 1 out of 5 is 120. And the probability of male 2 followed by male 4 is 0 because that violates the scheme for this stratified sampling approach. Whereas in simple random sampling, the probability of male 1 followed by female 1 is still your 1 out of 9 times 1 out of 8 is 1 over 72. And the probability of male 2 followed by male 4 is not a violation of the scheme. Just 1/9 times 1/8 equals 1 over 72. You see, in a simple random sample, each subgroup of size 2 in this case is equally likely to be selected. It's 1 over 72 all the way down. Whereas in stratified sampling, the probability of each ordered subgroup of size 2 is not the same for each subgroup of size 2. There are some subgroups of size 2 where the probability is 1 out of 20, and there's other subgroups of size 2 where the probability is 0. So that's one thing that we just looked at briefly at the beginning. Now, the other thing we're going to look at is a video clip from the movie Contact, which requires you to remember what's going on with calculating conditional probabilities based on a null hypothesis. And we did review the earlier example where you remember there was a student up at my keyboard trying to hack into my Chase checking account. And I'd like to do a variation on that. What is the probability that a person types my Chase password correctly? What's the probability that we observe this? Here's the eyeball. What's the probability that we observe someone typing my password incorrectly, given this vertical slash is for given that person, instead of a null hypothesis, I'm going to say, given that that person is yours truly. That person is Neil Roys. So that is the belief statement. So that probability would be A, breathtakingly low. B, it's multiple choice, very low. C, high. D, very high. Or E, awkwardly close to the number 1. By the way, breathtakingly low is very close to 0. Close to 0. And E is awkwardly close to 1. Not 0.9 repeating, because that is equal to 1. 0.9 repeating is equal to 1. It's a true statement. So anyway, the point is that the probability is based on the belief. Pause the camera and see if you can figure out whether it's A, B, C, D, or E. The pause button. Just like this, please. All right, now press pause again to unpause it. Except if you're on pause right now, you're not receiving that instruction. So, let's it's rough sledding for you. If you are Neil Roys, the probability that a person types the Chase password correctly, Mr. Roy's password correctly, given that the person is Roy's, it's E, awkwardly close to 1. It doesn't have to be exactly 1. Sometimes even I make mistakes in typing my password. So that's just illustrating the fact that the probability, when it's conditional based on a hypothesis, depends on the belief. The probability of what you observe, given what you believe, depends on what you believe. Had it been that person is not Neil Roys, then it would have been breathtakingly close to 0. Now, in the movie Contact, there is a conditional probability. And we're actually going to view that clip again in class because there's a lot in that clip. But your responsibility is to figure out what is the eyeball statement and what is the belief statement in the movie Contact when the observation is, and they're listening. They're in movie Contact, Jodie Foster's character, Dr. Ellie Arroway, has headphones on, and there's these big radio telescopes that are pointed in outer space. This is not fiction. This is going on right now in New Mexico at an organization called SETI, S-E-T-I, the Search for Extraterrestrial Intelligence. It's an acronym. And in New Mexico, Google it. They have the VLA, which is a very large array or arrangement of, it's hard to see that, very large arrangement of radio telescopes. So SETI is the Search for Extraterrestrial Intelligence, and they make observations. Most of the time they're sitting around listening to nothing, but in the movie Contact, which is based on Carl Sagan's book by the same name, they have they have a scene in which what is observed is, she hears it on the headphones. Boom. She starts out with 2 booms. It goes boom, 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 boom. 2 booms, 3 booms, 5 booms, 7 booms. And then she makes an observation. 2, 3, 5, 7. She says there's no way that's a natural phenomenon. What she's doing there is saying that she says those are prime numbers. 2, 3, 5, 7. They end up observing all the prime numbers from 2 to 101. What's the probability that you observe the prime numbers 2 to 101? They check to see, is this a prank? Is it coming from somewhere nearby? No, it's from a source called the Vega star system, which does happen to be the star system that's closest to Earth. It's only 26 light years away. So what's the probability that we get these radio signals coming from Vega that pulse out the prime numbers, given that the cause of this is so it's caused by either natural law, like there's some law of nature that causes pulsars to emit pulses in prime number sequences. So natural law or accident. There's no unseen intelligent agent. It's natural law or accident is that's the belief in this hypothesis, that the only agents that are capable of causing the effect that we observe are natural laws or accident. Now, of course, if it were just a natural law, that would promote the question, okay, well, who authored that law? But suppose we just have natural law and accident causing it. What's the probability of us observing that? Well, when she says there's no way that's a natural phenomenon, she's rejecting this null hypothesis, and she is at that moment concluding, and they check with people in Australia to see if they're observing the same thing, but they conclude that, and here's a conclusion, that because the probability, this conditional probability, is so close to zero, we reject the null hypothesis. We reject the null hypothesis. We reject this hypothesis that the prime numbers came from outer space near Vega by natural causes or by accident. The null hypothesis. The second sentence is the sentence that contains either the phrase sufficient evidence or insufficient evidence. There is sufficient evidence. What we observe is evidence, sufficient evidence that an unseen intelligent agent, those are the only options for causing effects. The only causes available, categorically speaking, are natural causes, accidental causes, or both of those are non-intelligent, or intelligent causes, like a person acting. Unseen intelligent agent caused the prime numbers to be sent. So this has deep philosophical, not only implications, but it reveals something about science that sometimes people are reluctant to admit, and that is that science has the capacity to detect unseen intelligence. This happens every time it happens at an autopsy, when the dead body effect is observed, and then sometimes the patterns observed indicate that we don't reject the null hypothesis, that it's either natural causes or accidental causes, but then sometimes the forensic scientist will conclude that no, there are signs. What we're observing here in this body cause us to realize that the probability of observing these patterns, given that it's natural or accidental causes, are so uncomfortably close to zero that we have to reject the null hypothesis and conclude that there is an unseen intelligent agent responsible for the effect. So it's either homicide or suicide. Same thing with fire science. We come to the scene of the fire, we observe what's going on and conclude whether it was arson or not. Science has the capacity to detect unseen intelligent agents. And later on in the movie Contact, they dissect the message further and they discover that it contains blueprints for building a spacecraft capable of interstellar travel. And so then all of the rational people, as depicted by the movie, reject the null hypothesis and realize, okay, there's persons out there, there are creatures that have sent us these blueprints to build the spacecraft. The question is, do we build that? What is the nature of these unseen intelligent agents? Are they hostile? Are they friendly? And so it's only the religious fanatics, as depicted by the movie Contact, that fail to reject the null hypothesis and that still think that there's no intelligence out there. So you have to watch the movie to get more context on that. But the point is this: when you acknowledge that science is capable of detecting unseen intelligence, then what if you were to metaphorically take these radio telescopes, and again, just Google VLA, New Mexico, and you'll see what these radio telescopes look like. What if we were to metaphorically take them and point them at the nucleus of every cell in our body, except for the red blood cells, which lack a nucleus, and then ask yourselves, what's the probability that we observe blueprints for building our entire body, our DNA, in the nucleus of our cells, given that we ourselves are not the product of an unseen intelligent agent? So think about that one. We'll see you in class. Enjoy the rest of your weekend.